Hi, Michelle Glass here. Welcome back to another episode in our Chapter 19, Lecture 19 series. And our topic for this video are our white blood cells, which we can abbreviate WBCs. And we also have another name here, which is the leukocyte. So just like RBCs, red blood cells, could be called erythrocytes, white blood cells, WBCs, can be called leukocytes. And the name here is similar to what we saw before, where that prefix leuko means white, and then cyte, C-Y-T-E ending, of course, means cell. Now, white blood cells have some characteristics that are unique and special to them. One of these characteristics here that we need to point out is that even though this is in our group of formed elements of our blood, these are full-on cells. So in our red blood cells, we talked about them kicking out the nucleus and other organelles. And in the case of the white blood cell, that's not the case. So these are cells just like you're expecting to see, just like you've studied in your chapter 3 way long time ago. These cells are nucleated. They contain organelles, so they have all of those structures that you're expecting to see. Now we have 3 important features or characteristics that are special about white blood cells. The first important characteristic is that they are able to emigrate. So here, emigrate with the E means to leave. The immigration with the I is the showing up at the place that's new, right? Okay, so we can also describe this as diapedesis. Diapedesis is talking about this ability of the red blood cell to actually squeeze itself out of the capillary. So it can fit through what are called the endothelial cells. The endothelial cells are the cells of the capillary wall. And then those white blood cells can actually get in there and squeeze in between and exit circulation. And we will see then that the white blood cells will be taking up residence in connective tissues. So think of like areolar as a key example, but not the only example. We will find white blood cells in our lymphatic organs. So we're going to be talking about these again in chapter 22. And we'll see that white blood cells will show up at areas where injury has occurred or where infection has occurred, because our white blood cells are our defense cells. These are our cells of our immune response that are helping to identify foreign invaders and target them and phagocytize them and remove them. So we're going to be talking about them here and then again in chapter 22 when we're studying the lymphatic system. Because our white blood cells can leave circulation, we don't see a whole lot of them actually in circulation. We've already mentioned that the red blood cells are the majority of the formed elements in the cardiovascular system. That's not because we don't have a lot of white blood cells in the body. We do. We just don't have a lot of them actually in circulation because they leave, okay? So not only can white blood cells leave the actual cardiovascular system, but they can move through the body. So we describe this as amoeboid movement. I'm super proud of my little animation, so let's do it again. Do, 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 do. Okay. So this is how they can actually show up at places of injury or infection. And how do they know where to go? They're gonna smell it. So they're using what's called positive chemotaxis. So my white blood cell here was super attracted to that chocolate chip cookie. But reality would be, of course, not cookies, but instead pathogens. When tissue is damaged, it will release some eicosanoids, some local hormones. That's that paracrine type of communication that's going to attract white blood cells. If you have active white blood cells in the area, they will be releasing chemicals to attract more white blood cells. So it's kind of like a positive feedback mechanism. The more white blood cells you have, the more white blood cells are going to show up to that area. So our three important features that we see for our white blood cells are that they can immigrate or perform diapetesis, meaning actually squeeze out of our capillary. Then they can move using amoeboid movement. Amoeboid movement is where you're sticking out a part of your cell and then moving in the direction of that cell. And then they can move in the direction of a chemical stimuli, and we refer to that as positive chemotaxis. Positive chemotaxis means you're moving in the direction of, instead of away from, a chemical signal. Chemotaxis just means it's a chemical stimulus that's causing the movement. Taxis, like taxi, just is talking about movement. All right, and that's it for now.